Hello everyone. This is experiment 10 in BCT done by Dhairya, Anisha and Nabodita. So, introduction. Blockchain provides a decentralized peer-to-peer network where digital assets can be transferred from one peer to another. Ethereum is a decentralized platform that allows us to write applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. It consists of Ethereum virtual machine, which provides the container in which all the smart contracts can be executed. Ethereum allows us to write applications on the blockchain, and these applications are known as smart contracts. These smart contracts reside on the blockchain and they are immutable in nature. That is, the code cannot be deleted or modified in blockchain once it is deployed. This can be written using Solidity or other languages, but the most preferred is Solidity. The basic workflow for Ethereum can be described as we can write smart contracts and deploy them on Ethereum network. Once deployed, these contracts cannot be changed. Any account or another smart contract in the network can execute these smart contracts functions through transactions. These transactions costs gas, and a certain gas should also be sent along with the transaction. Sometimes we just need to know the state of some contract without modifying the blockchain. We can build various D applications by executing the smart contract using transaction calls, thus allowing the user to directly interact with the smart contract in different ways. Nabodita will continue.
Project details. This report details the creation of an e-voting application using Ethereum. Ethereum, a blockchain platform, can be used for e-voting by leveraging its smart contract capabilities and decentralized nature to create a secure and transparent electronic voting system. Here are the key steps and considerations for using Ethereum for e-voting. Smart contracts. Ethereum allows the creation of self-executing smart contracts, which can be programmed to handle various aspects of the voting process. These contracts can automate the registration of voters, validation of their eligibility, and counting of votes. Next, voter registration. Voters can register on the Ethereum blockchain, and their identity and eligibility can be verified through means such as government-issued digital IDs or other authentication methods. Casting votes. Voters can cast their votes by interacting with a smart contract on the Ethereum platform. The vote is recorded on the blockchain, ensuring immutability and transparency. Testing and security audits. Rigorous testing and security audits are essential to ensure the system's integrity and protect it from potential vulnerabilities or attacks. User-friendly interfaces. User-friendly interfaces and mobile applications can be built to make the voting process intuitive and accessible to a wide range of users. Legal and regulatory compliance. E-voting systems should comply with relevant legal and regulatory requirements. Different jurisdictions may have specific rules and standards for electronic voting. Off-chain oracles. To ensure that real-world events elections in this case, are accurately recorded on the blockchain, external data sources called oracles can be used to feed information to smart contracts. Testing and pilots. Before implementing a full-scale e-voting system on Ethereum, it is advisable to conduct smaller-scale test and pilot programs to identify and address potential issues. Anisha will mention the rest.
So why use Ethereum for e-voting? Firstly, privacy and security. Maintaining voter privacy is crucial. One way to achieve this is by using cryptographic techniques to encrypt the vote and ensure that only authorized parties can decrypt and count the votes. Zero knowledge proof can be used to verify a voter's eligibility without revealing their identity. Second, transparency. Ethereum's blockchain is public, so anyone can audit the voting process. All transactions, including the casting and counting of votes, are visible on the blockchain, enhancing transparency. Decentralization. Ethereum is a decentralized platform, meaning that there is no single point of failure. This reduces the risk of manipulation or interference in the voting process. Verification. Anyone can independently verify the results by examining the blockchain. This ensures the integrity. Accessibility. Electronic voting systems should be designed to be accessible to all eligible voters, including those with disabilities. Ethereum-based systems should consider accessibility standards and features. Now, the area will show the implementation.
Okay, so for the implementation of this project, the tech stack that we have used is Monstack for the web development and Solidity for writing the contracts. And we're using MetaMask for transactions. And we're deploying the contracts on Truffle Ganache test network. So I will start by explaining the project structure. We have the blockchain folder under which we have migrations and the different contracts and the different components that are used in the front end of the project. For the backend, in the server side, we have the database on Mongoose, like MongoDB, and the different models that we have created for the database. Coming on to the demonstration of the workflow, here we have the user where when we log in, we can see the different elections that are that are happening currently. So if we enter Maharashtra, we can see that there are two candidates that we have enrolled, and we can vote for any of these candidates. So the voting requires approval from the MetaMask wallet transaction, and we can confirm this transaction. Now, when we go to the elections and see the view vote count, we will be able to see that the vote has been casted. We can even create any new elections. So now we can see that the election has been created, and we can add different candidates for this election. So I will demonstrate the candidate. So now the candidate has been added. We can see that the candidate has been added and we can vote for the particular candidate. On the Ganache platform, we can see the different transactions that were placed and the gas used for each of these transactions. This is it for the project. Thank you.